Hello and welcome to Think Academy July Grade 1 Challenge question number 1. So let's start with the questions. And the question number 1 is to observe the picture below and write 4 different equations. To begin, what do I have over here? So I have pears, right? I have fruits of the color yellow and green. And are they all the same or there's something different about it? There's difference in size, right? So I see small and also large pears. And over here, we have a total of 2 rows. So I have row number 1 and also row number 2. And how many pears are in each row? For the very first row, how many pears are there? There are 1, 2, 3, 4, 5, 6. When we count. And the second row, there are another 6. So it's the same for both rows. But how are we going to make 4 different equations? We can start with the total. So why don't we look for the total number of pears first by adding up the row? So row 1 has 6 pears and row 2 has another 6. So that gives us 12. Great. So we have found our very first equation. Still in the total, we can calculate the total in a second way. So we can count on how many are there for small pears and how many are the large pears. And so, how many are there for small one? There are 8. And how many are there for the large ones? There are 4. In total, 8 plus 4, that gives us 12. Great. So we know that the total is 12. And why don't we move on to a different kind of equation? We can also find from the total what is the number of small and what is the number of large. Why don't we start with large? So this will be our third equation. How can we find the large if we already know the total? Are we adding or are we minusing? We minus it, right? And if we want to find the large ones, we minus the number with the small pears, right? And that is 8. So we know that we have how many large pears? We have 4. Great. And what about our very last equation, the fourth one? We can find the small one. And how do we do that? We can start from the total again, right? And what should we minus this time? We should minus the number of large ones, which are 4. And that gives us 8 small pears. Okay, that is just an excellent work. So we have found 4 different equations to be made. 2 from total, 1 from large, and 1 from small, counting from total. And now, why don't we move on to the second question? Joanna has 4 number cards on the table, and she wants to use them to make numbers. Here we have 4 number cards, 2, 7, 8, and 4. We want to make, first, the largest 2-digit number. So, if we want to make 2-digit number, how do a 2-digit number looks like? So, first, you have something on the 10th place and something on the 1's place. For example, I have a 1 and 2. So, I have 12, and this is a 2-digit number, an example of 2-digit number. So, if the first one we're going to make numbers, the largest one, so are we going to find the larger number or the smaller number? We're going to start with the largest. So, what is the largest number from the 4 cards? It's 8, and then we have 7. Now, we're going to form the 2-digit number. If we're going to make the largest 2-digit number, then we're going to place the larger number on the 10th place or the smaller number. we're going to place the larger number so that it makes the bigger number. If we do that, then we have 87. And 87 is bigger than 78, right? Okay, so we're done with 1. And the second one, we're going to make the smallest 2-digit number with the smallest number. So the smallest number, what is that? It's 2. And then, what is the second smallest? We have 4. So from 2 and 4, if we want to make the smallest 2-digit number, then we have to start with the smaller number for the 10-digit or the larger. So we're going to have the smaller one, right? That gives us 24. And 24 is smaller than 42, our second option. So we have the 2 largest and smallest 2-digit number. But we're not done yet because with our cards, now we're going to make the largest 3-digit number. Now, how do we make a 3-digit number? So let me give you an example. We will have something on the 100 and then on 10 and 1. So we have an addition of the 100 over here. If we are doing this, for example, I have 1 as the 100, 2 as the 1, 2 as the 10, and 3 as the 1. So here I have 3-digit number 123. So if I want to find the largest 3-digit number that can be formed, then I'm going to start for the largest with the largest number, right? And we already know from the same 4 cards, it's 8 and 7. And what's next? What's the third largest? Is it 2 or 4? It's 4. So we have 8, 7, and 4. And if we're making the largest 3-digit number, we'll be forming with the larger number on the 100. And it gives us 874. Now, what about the smallest 3-digit number that can be formed? So we'll be starting with the smallest. And we already know it's 2 and 4. But what's the third smallest number from the cards? Is it 7 or 8? It's 7, right? And that makes us form from the 100 place. We start with the smallest and giving us 247. Okay, so that's it for question number 2. And we're moving on again to question number 3. So over here, we see that Mia eats 18 sandwiches. Jack eats 7 less than Mia. And Mark eats 6 less than Jack. So how many sandwiches does Mark eat? Do we know how many sandwiches does Mark eat? We do not know this one. But we know something. So who do we know? That will be Mia, right? Mia, we know that she eats 18 sandwiches. And if we know Mia, next, we can also look for Jack, right? So, Jack eats 7 less than Mia. If we see the word less than, this means we are adding or we are using minus. We are using minus. So, from the starting point of Mia, we're going to have Jack as the number of sandwiches that Mia eats, but it is 7 less than Mia. So this gives us 11 sandwiches. Okay, that is perfect. And we're going to move on to the next one, which is Mark. So for Mark, he eats 6 less than Jack. And we already know how many sandwiches does Jack eat, right? And how many is there? 11. So from Jack, and we know less, that means minus. If we are minusing from Jack, we'll be minusing how many? 6. And That gives us, for Mark, how many sandwiches? 5. So now, have we reached our answer? Yes, because we're looking for how many sandwiches does Mark eat? And that is 5 sandwiches. So that is another great work. Okay, moving on to question number 4. Over here, Nini folds the square in half. And then she folds the square again in half to the right. After that, she cuts some special shapes in the corners as shown below. What does the unfolded shape look like? So we're looking for the unfolded shape. And we can see the step by step what Nini is doing over here. From A to B to C to D, the cut shape. But if we're going to unfold it, then we're going to move backward. So from D, if we are moving backward like that, then what should we do? How do we know what will it look like? Why don't we start with the vertical symmetry? So since this one is a square, it will look exactly alike. If we're looking at B, if we are unfolding from D, so it will be like that. And if this is D, the other end will be the reflection of D. So why don't we try and look at what the reflection would look like on D? Vertical symmetry. So we can make the vertical line from top to bottom. And now we have it in the middle over here. And on D, we can see it goes up. But now I'm going to make the reflection of it. So it's a flipped version. And I can have it like that. So this will be the same length. And I can draw a line to there. And this gives me the very first reflection. But we're not done yet. And from this point, I'm going to move to the straight line over here. So if I'm going to make the straight line, I'm going to make a same distance. And from the other point, I'm going to pull it. And this gives me the reflection, right? So now, doing the same thing. So I have a line downward. And then I have a curve. A little bit of line to the right. And then a line up. And this is how I get my reflection. If I already have my reflection looking like this, now we are still not done. We need to make the horizontal reflection. So we're going to pull on a horizontal line. And if we're pulling on a horizontal line, and we are going to copy this one over here on the very middle. So if I'm pulling it, it will be over here. And I can pull 2 lines over here. And this gives me the middle shape. So we can observe from A, B, C, and D. So A has a square, B has the circle, and D has the other shape. So which shape looks exactly like the one that I just drew? It will be D, right? So D is our unfolded shape. And if you want to complete the picture, you can also do it over here like that and pulling down, going like that. So I have the picture exactly like D when I'm drawing the horizontal reflection of our shape. And we can also do what Nini does and fold the square paper in half and another half and cut it to the shape and unfold it, and we will get the shape D. That's how we can prove it. So after we're learning about symmetry, we're going to move on to count the following shapes. The first one is a triangle. So we're going to count how many triangles are there. If we're counting the triangle, we can do it by one smaller triangle? And can we do it by two smaller triangles? Or 3, 4, 5? Yes. So we can do until 4 because we only have 4 smaller triangles, right? So why don't we start with the smallest one, with one triangle? So if I have one triangle, I'm doing it on order, counting from left to the right. Then I have 1, 2, 3, and 4, right? So I have 4 triangles. And now what about, I'm looking for group of 2 triangles. So starting from the very left, I have from 1 to 2. This is my first one. And 2, 2, 3. This is my second one. And from 3 to 4. This is my third one. Can I have more of the group of 2? No, this is all that I can make, right? So I can make 3. So now why don't we move on to a group of 3 triangles? So how many can I make? So pulling from 1, 2, 3. I'm going to make 1, right? And then pulling from 2 to 4, I'm going to have 2. So in a group of 3 triangles, I have 2. And now I have the last one. So what if I want to make a group of 4 triangle? Then how many can I make? I can only make 1, right? Because I only have 4 triangles, 4 smaller triangles. And can I make a group from 5 smaller triangles? No, because we only have 4. Okay, now I want to count the total. And counting the total, we have 4 plus 3 plus 2 plus 1. And that gives us 10 triangles. Okay, so we have our answer for the triangles. And why don't we move on to our second shape, which is the rectangles. So over here on the rectangles, I can start with a group of 1, right? So 1 rectangle. If I'm starting with a group of 1 rectangle, so how many can I have? In order from left to right, I have 1, 2, 3, and 4. So I have a total of 4 rectangles. And what about a group of 2 rectangles? So I can have from 1 to 2, 1. And from 2 to 3, I have 2. And from 3 to 4, I have 3. So now I have 3 rectangles. And what if I do a group of 3? So now, if I do a group of 3 rectangles, then I can start from 1 till 3, right? So this is my first one. And another, I can start from 2 to 4 because I'm doing it in order. So I have 2 now. But can I have more? No, I can only have 2 of a group of 3 rectangle. Great. Now, can we have a group of 4 rectangle? Yes, we can have a group of 4 rectangle. And so, how many can we make? We can only make 1 because we only have 4 rectangles. Okay, that is just very, very great. And I want to know, for the very last one, how many rectangles do we have on the following shape? So we have to count the total, which is 4, plus 3, plus 2, plus 1, which gives us 10. So in total, we have 10 rectangles. And that's all for counting the shapes. So we have counted the shapes of the triangle and also rectangle. We are doing it in order from left to right and also from smallest group of 1 to the biggest group of 4, since that's the most we can make with our smaller rectangles. Okay, and thank you for watching, and I hope to see you soon at Think Academy.